Right, so we're going to start off by doing a little bit of review of coordinates, axes, quadrants, how we graph points. And we're going to spend the next couple weeks on graphing and that kind of stuff. So it's a good idea just to kind of start with the basics and then we'll build up from there. So way back, okay, probably first, second day of school, we talked about a number line and how we graph a point on it. Okay, so this problem just shows you how to represent 4 on a number line. Okay, anytime we want to represent a location, we use a dot. Okay, we're going to do the same thing today. We're going to use a dot to represent a location. Okay, now, a number line, basically, how many dimensions is that? Like, how many directions can you move? Like in terms of horizontal, vertical, forward and back. How many directions can you move here? Just one, just horizontal. Right? All you got's left and right. All right, so that's a little bit easier. Okay, it's like one-dimensional. Because it's one-dimensional, we only need one number. Okay? If I said, how would you mark that spot right there? Okay, how would you represent it? It's just the number 1. It's not 1 comma something. It's just the number 1. Okay, but if we want to represent a point on a plane, okay, we need 2 numbers. Okay, we need 2 numbers. Because we have 2 directions we can move. We can move left and right, and we can move up and down. So these 2 numbers make up what it's called a coordinate. Okay, and you've got a spot on your notes to write that word in, coordinate. Does anybody know the other name for a coordinate? It's actually 2 words. Yeah? Yeah, you can also call it an ordered pair. Okay, a coordinate or an ordered pair, same thing. Right? That's how you locate a point on a plane. All right, so here's what it looks like. Okay, when we write a coordinate or an ordered pair, we put it in parentheses. Okay, we write both numbers in the parentheses, and we put a comma between them. All right. Okay, how many people have done that before? Coordinates, and yeah, people have done that. All right, so the space where we put all these points, okay, where we actually do the graphing, it's called a coordinate plane. It's basically where we're going to put our points that we graph.
So guys, on your notes, we wrote in that's called a coordinates or ordered pair. It says the blank is first, and then the blank coordinate is last. So how are you going to fill in that first blank? Which coordinate is going to be first?
X.
The x, right? So fill in that blank with x, right? The x coordinate is first, and then it's another blank. What's the other blank going to be? Y, right? The x is first, the y coordinate is last. So make sure you fill those 2 bullets in with x and y. And again, like Mr. Hager said, that's kind of review stuff. That's stuff you know.
And if you ever forget, it's alphabetical order. X before Y. Okay? Okay, now, when we draw a plane, okay, we have an X something and a Y something. Does anybody know what are the names of those 2 things? The X.
The X and Y axis?
Yeah, the X-axis and the Y-axis. And together, those make up your axes. Plural. Okay? So we've got a picture. Well, I'm going to label it and show you all this as a diagram in a second. Now, your X-axis and your Y-axis, okay, they cross at a special point. Does anybody know the name of the point where they cross? Justin? You know that point? Get your 2 axes, that point right there? It's kind of where everything starts from. So if you think of like the word, like where everything starts from, where it comes from, it's, yeah? Okay, yeah, it does have to do with 0, yeah. But there's actually a word for it. Origin, yeah, origin. All right. So your two axes intersect at a point we call the origin. Okay? Origin, it's where everything starts from. Anytime you're going to graph, you start from there. It's kind of where everything comes from. Think of it that way, the word origin. Okay, and those two axes we're going to draw. The x-axis is horizontal, and the y-axis is vertical. All right, so let's look at a picture. All right, so we're going to kind of just go through and quick explain what's going on here. All right, so first thing, I got a little bit of graph paper in the background so we can see our points. Okay, we've got our two axes. The horizontal I labeled x. The vertical is y. Somebody explain, what is this positive, negative stuff? What does that mean? How do you explain that? Rose?
There's the two quadrants in the
All right, so yeah, we're going to talk about that in a second too. We got these four spaces here called quadrants. But what is this like positive and then arrow to the right mean?
Oh.
Yeah.
So it's like a number line. So the after 0 is like positive and then before 0 is negative.
Yeah. Basically, it's like a number line in each direction. Okay. The horizontal one has the positives to the right, negatives to the left. Okay. That's your x-axis. Okay. On your y-axis, positives go up, negatives go down. Okay. And then we're showing you what the sign, okay, or what the positive and negative value of a coordinate would be in each one of these four spaces, which Rose already told us is called quadrants. Right? So if you had a point in the upper right, it would be a positive number and another positive number. The first number would be positive, and the second would be positive. Okay? What about in the upper left? If you're in the upper left, the first number would be what, Victor? The first number?
Oh, no, it's negative.
And then the second number?
Yeah.
Positive. All right?
You guys have those parentheses on your graph, is that the fill in, that's all.
Okay, and likewise, if you were in the lower left, okay, you'd have a negative number, comma, negative number. Negative for x means go left. Negative for y means go down. Okay, and this we already said, or Rose said it. The x and y axis, take this grid, take this coordinate plane, break it up into four sections we call quadrants. This is how you number them. Okay, that's a little weird, but you just start with 1 in the upper right.
And Mr. Hager did them on two separate graphs. You guys just have it on one graph on yours. Just, you have quadrant, and it says blank. So just fill in the blank with those numbers. Because on the homework and maybe on the test, we might ask you to tell us what the point is and also identify what quadrant.
So 1's in the upper right, and
So
then
we
they go
got
counterclockwise. 2, 3, 4. Okay, so no matter where you put a point on this coordinate plane, it can only be in two places. It's either in a quadrant, okay, like that, or if I do something like that, that's not in a quadrant. That's on an axis. Okay? Or if it's at the origin, that's the only point that can be on both axes at the same time. Does everyone see that? How that point at the origin, it's on both axes at the same time? All right. All right, so if we want to plot a point, okay, basically what this is saying, there's only one way to do it. Okay, if I asked you to graph the point 2, 3, there's only one spot you can put the point 2, 3, okay, and get it correct. Right? So every point has its own unique coordinate. Okay? All right, so how do we graph a point?
So you guys have some space for this, so you just need to write it in.
Always start at the origin. What's my first number when I write a coordinate? Which letter is that? X, and the second one? Y. Okay, so you're going to deal with this one first. Okay, and you have two directions you can move. Okay, the x-axis, which one is that? Horizontal or vertical? That's the horizontal. So you either can move left or you can move right. Oh, you move left if the first number is negative. Right, you move left if the first number is negative. Move right if the first number is positive. Well, there's actually one more case. What if the first number was 0? We just stay there. Yeah, we don't move. Yeah. So if the first number is negative, move left. Positive, move right. All right, so now that takes care of our x-axis, our horizontal. Now which one do we got to think about? Yeah, the vertical. We got to think about the y. Okay, so from where we just moved in step 1, now from that point we're either going to move up or down. How do you think we're going to know to move up? What kind of number would we have for y if we're going to go up? Yeah, positive. What about if we're going to go down? Negative. Yeah. All right. So for your y-axis, move down if the second number is negative. Move up if the second number is positive. Okay, and we also could have that third case. What if the second number is 0? Then what happens? Caitlin? Yeah, we stay right where we are. All right, if the second number is 0, we don't move up or down. So if either the x is 0 or the y is 0, we're not in a quadrant. We're going to be on an axis. Yeah?
I have a question. Like, so if you're making like a shape in there, and like the last one you had is like in like negatives, and then like your next y thing is still negative, but it's going up, would that still count? Like, would that still work for that?
What's your question again, Rose? If you did what?
If you're making a shape in like coordinates and whatnot, and you're like the coordinate you just did was like in the negatives, and then your like next coordinate, like its y-axis is like negative, but it's higher than the first one.
So like that or something?
Yeah.
Yeah?
That would still work for your
Yeah, these steps always work.
okay.
Yeah, they always work. It doesn't matter positives, negatives. They even work for fractions and decimals. Decimals can be hard to graph. So we generally stick to integers, numbers without decimals. Hey, so just to kind of summarize, we already said this, but your x, that gives you your horizontal movement. That's your left and right. Your y, that's your vertical. That's your up and down. All right, so that was a lot of writing. Okay, we had a lot of just background stuff to get through. Now we'll just we'll do a few examples, and then we'll be done with section 10.1, and then we'll look at 10.2. Okay, does everybody have that? Good. All right, so on this one, they're asking us to graph some points. All right, Corey, can you tell me, how do I graph the point, first one, 5, -3? All right, so to the right 5, like that? Just start right here? Okay, and go right 5, and then what? Oh, all right, I got to start at the origin. All right, so I got to go right 5. I like that idea, but I got to make sure I start at the origin. All right.
Then you got to go down 3.
And then down 3. How do you know down?
Because it's negative.
Yeah, because it's negative. Good. All right, so that's the point 5, -3. I was going to ask you which quadrant it's in, but we're going to get to that in another problem. -2, -8. Yeah, Victor, you think you got that one?
Yeah, would you go to the left?
Left 2? All right, so start over here. Go left 2.
Oh, yeah.
All right, start at the origin, left 2.
Yeah.
All right, I like that, left 2, yeah?
Go down, 8.
Yeah, and then down 8. That's it. So that's the point, -2, -8. Ryan, how about -5, 1?
You start at the origin
All right.
and you go down -5.
Okay. And then what?
And then right 1.
All right. Which letter is this again?
-5.
Yeah, which out of X and Y, though? Which letter is it?
Oh, it's Y.
Remember, alphabetical order. Which
Oh,
one
X.
comes first? Yeah. And is X my horizontal or my vertical?
It's horizontal.
It's horizontal. So instead of down 5, we're going to go
Right 5.
look at the kind of number it is. So right means we have a positive number first. You agree that's positive?
No.
No. So which way do we go?
Left.
Left 5. Okay. And then the 1 says to go which way?
Up.
Up, yeah. Okay, so up 1. Right, so that's -5, 1. All right, so we got a point in each quadrant so far. We got one more. Yep, Alex, you want to give us the last one?
So you start at the origin and then you go over to the right 5.
Hey, I like how he said to the right. At first, when you said over, I was going to be like, which way was over? But you already got it. Right 5, perfect.
And then up to.
And then up 2. Okay, so there's a point in each quadrant. These last 2 points have zeros in them. If you've got a 0, you're not in a quadrant. Where are you if you're not in a quadrant? You're on an axis, either X or Y. Or you could be at the origin if you had 0, 0. So yeah, Victor, you're going to tell me 0, 3?
You just go over 3 to the right.
Right? Is this my horizontal or vertical, this first one?
Go through the
Down. Up and then up.
Yeah. Up.
3 up and then
There's margin.
Okay, so that one, 0 left and right. We're not moving left and right.
down.
Positive 3 for Y, up 3. All right?
So then the next one we can go left is -4 times.
Yeah, you can just say left 4. That's fine. Yeah, left 4. And then what about up and down?
You don't go up and down.
We don't go up and down. We have a 0 for Y. Yeah. Okay, so that's an example of how you graph points. All right. All right, so let's just see if we can kind of do the reverse now. I've given you points. I want to know what the coordinate is to get to them. Do you guys already have the coordinates on your paper? All right. Otherwise, I think that's hard to see if you're in the back. I was going to make it bigger, but you guys are good. All right, look at A. Vic's on fire today. Vic, what do you got? What's A?
Would it be 4 and then it would be 3?
Yep. Right 4, up 3. Okay, that's A. Okay, Davin, how about B?
You go to the left 7, up 1.
I like it. Left 7, up 1. And what does left mean? Is that a positive or negative?
Negative.
Good. All right. C. How about Sam?
And then you go to the left 1, -1,
Yep. So -1 and -2. Right. And D. How about Ben? What do we get for D?
You go to the right 3
Yep. Right 3.
and down 8.
Yep. Right 3, down 8. Can you just tell me how to write it?
3, -8.
Perfect. Okay, and E. Okay, last one. I'll do this one. Okay, I'm on an axis. Right. This time I'm not going left and right. So what number do I use for left and right? 0. I'm going up 8. Okay, up 8. All right, so you guys should feel pretty comfortable with that. Either I give you a letter, you tell me the coordinate, or I give you a coordinate and you graph it. Okay, either way. All right, next part, all I want to know here is the quadrant. Okay, you don't have to tell me how to graph it. I just want to know the quadrant I'm in. Okay, point A, if you were to graph it, where would it end up? Rose? Yeah. 3 is right, 4 is up. If you go right and up, you're in quadrant 1. Now, sometimes you see quadrants written with Roman numerals. Has anybody ever seen it that way? I don't know why. A lot of books do that. You guys can just write the number.
Yeah, let's put the Roman numeral.
All right, B. Yeah, Victor? Let's see. We're going to go left is negative, up is positive. I like it. 2. All right. How about gauge? How about C? Yeah, we're going to go right and down. It doesn't even matter how much, right? You're just going right, you're going down. Quadrant 4. D is left and down. That's 3. Okay, be careful with this last one. What about E?
Y-axis.
You're on the y-axis, so it's almost like a trick question. You're not in a quadrant. You went up 2. You're on the y-axis.
Mr. Hager, would you accept, like, if they put nothing there or no access, would you accept that, or do you want them to put y-axis?
I guess if it said identify the quadrant, they could write not in a quadrant.
Okay.
Yeah,
No quadrant, none.
you could say it's not in a quadrant. Otherwise, if you wrote this y-axis, that's fine too.
All right.
Either way. I'll put that in parentheses. It's not in a quadrant. Okay, and last one, and then this will be the end of our review. Okay, it gives us these 3 vertices, and it says they make
Bottom right corner.
a rectangle. Okay, what I'm going to do, I think the easiest way is to visualize it. Okay, graph these points. 1, 1. Okay, 6, 1, and you guys got a grid to do this on, so.
Sure.
Yep. Okay, 6, 4. Right 6, up 4. So what they're asking is, what would be the coordinates of the 4th vertex to make a rectangle? Okay, so what would be my last coordinate here? If I put it in, I'd have a rectangle. Did they see it? Yeah, Ryan?
It's 1/5.
Let's see, 1.
Yeah.
Yep, so right 1, and then what'd you say?
Up 5.
1, 2, 3, 4, 5.
4.
Yeah, I think we went up 1 too many. I like the right 1, but we just had to go up 4. 1, 4. Right? Now, you could do that without graphing it, but I think graphing it makes it easier. Then you can see it on graph paper rather than trying to picture it in your head. Okay, any questions on that? Can you guys feel okay with coordinates? Section 10.1? Kind of basic review stuff. All right.
That's in the notes for 10-2.
Okay, and 10.2 is just as short as 10.1.
And we're still doing coordinates and stuff like that, we're just using different names for them.
Okay, so in 10.2, we're going to take a closer look at coordinates. Okay, specifically, we're going to take a closer look at the x part, and then a closer look at the y part. Okay, what we call those. Okay, first thing, I just want you guys to read, okay, what's on the board. Okay, and you might notice a pattern. Okay, just take a second and just read that. Okay, it says Ann worked making $7 an hour. So if she worked for 1 hour and she makes $7 an hour, she makes $7. If she works for 2 hours, she makes double the money, she makes 14. 3 hours, she makes $21. 4 hours, she makes $28. Any questions on that? Just explaining how much money she makes. Right? As you read that, there's two different kinds of numbers in that problem. What are the two kinds of numbers we have in this problem? One of them represents something. The other one represents something else. Yeah? Yeah, one of them represents hours. Okay, so what I'm going to do is, I'm just going to put boxes around all the things that are hours. Okay, so that's one kind of thing. What's the other thing in this problem besides hours? Yeah? Money. All right, so in 1 hour, $7. 2, 14. 3, 21. 4, 28. Just by the way I was saying that, what do those kind of sound like? 1, 7, 2, 14, 3, 21, 4, 28. Those are basically coordinates, right? We could take all that data and instead of writing it out in words, we could just write it as coordinates and represent the same thing. Right? So the number of hours that she worked and the amount of money that she earned can be represented by, somebody said coordinate, same thing as an ordered pair. Right? So now we're actually using an ordered pair rather than just to graph something, to represent something in real life, like hours and money. Which ones would be the x's? Hours or money?
Hours?
Yeah, hours. Okay. X is always, think of X, it's like the one that's in control, right? Depending on how many hours you work, that is what's in control of how much money you make. The amount of money you make, well, that depends on how many hours you work. Okay, so hours is what controls your pay. So that's X. It's the first thing. We put it first. So how would we represent this first one? 1 hour, she earns $7. How would I write that?
But would it be like parentheses 1 and 3?
Yeah, it would be parentheses 1 comma 7. Okay. In 2 hours, $14. 3 hours, 21, and so on. Okay, and does everyone see this little bracket we put right here at the beginning and then one at the end? Okay. That bracket just means what's inside here is a set. Okay, and this is called a set of coordinates. Specifically, this is a set of how many coordinates? 4. Yeah, this is a set of 4 coordinates. So we just put these brackets just to group them together. Okay. Does anyone have any question on how these coordinates represent the hours and the money from the lifeguard problem? All right. Okay. What we have here, this is called a relation. Okay, think of it as a relationship. Okay? It's a relationship between how many hours this person worked and how much money they made. There's a relationship between those two things. Okay, so this set right here is called a relation. All right, now you guys already know one name for all these things. All those things I just circled in red, what are those? What are those? They're my what? Yeah, they're my x's. Okay, they're my x's. Okay, but another name for your x's, anybody know? Begins with a D. Kevin?
Domain.
Yeah, domains. Okay, so in that set, all the first coordinates, 1, 2, 3, 4, you could call those numbers the domain. Okay?
So that, guys, that stuff that's highlighted up there, that's where you're gonna fill in your blanks with.
Okay, so the domain, basically, it's just a list of everything I circled in red. It's the first part of each coordinate. So in our set, the domain is 1, 2, 3, 4. And I wrote it right here. That's the domain. It's all the different values we have for x. Okay, the domain is all the different values you can have for x. All right. Now we're going to look at the other part. Okay, we're going to look at the second half of the coordinate. Okay, we've got 7, 14, 21, 28. Okay, what are those? You don't have to give me the fancy word, just the word we have from the last section. So the red ones were my x's. Rose? Yeah, all the green ones are my y's. Okay, so in this problem, my y's are 7, 14, 21, 28. Well, we give a special name to the y's. Okay, does anybody know what we call those? Yeah, the range. Good. Okay, the range is a list of all the y values. Or you can also call it the second part of the coordinate. Same thing. Okay, so in our problem, the range is 7, 14, 21, and 28. Those are what I circled in green. Okay, and this idea of domain and range, you study it every class from now through calculus. Domain and range comes up a lot. All right, so domain, which letters are my domain? Those are my, Callan? My x's. Okay, and my range, those are my y's. Right? So that's a good thing to know for the test. Domain, x's, range, y's. Because what Mr. Roy and I will probably do is we'll give you a problem just like this. We won't circle anything, red and green. We'll just say, in this set, identify the domain. 1, 2, 3, 4. Okay. In this set, identify the range. 7, 14, 21, 28. So you need to know how to do that.
It's like x comes before y, right? And we have domain range. D comes before r.
Now, look at this one. Okay, a little different.
Mr. Hager, did you identify the domain and range for that last set?
Yeah. This one doesn't have numbers. Okay, you could have names. Maybe this represents a person and how old they are. Chris is 23, Scott's 19, James is also 19. Okay, so what's my domain here? What's my domain? Yep, Victor?
Could be James, Scott, and Chris.
Yeah, James, Chris, Scott. It doesn't matter the order you list them in. That's not important. Okay, so the domain, it's a set of 3 things. James, Chris, Scott. Any questions on that? Okay. Alexis, what's the other thing I can find besides domain? I can also find the. Oh, sorry. Yeah. The range. Yeah, I can find the range. That's what we're gonna do next. We're gonna find the range. Ariana, what's the range here? All right, so what do you think I'm going to write for the range? What you said is you identified all three of them. So what do you think I'm actually going to put right here? Say what you said one more time. Stop there. That's good. 1923. All right. If a value appears twice, you don't have to write it twice. All right. But what you identified was perfect. Those are all the values in the range. 19.
Jay, would you be wrong if you wrote it twice?
No, it technically wouldn't be wrong.
Okay.
No. But the range, it's a list of all the different values you have. I guess it'd kind of be like if you solved this problem and you said, x equals 2, and then just for the fun of it, you wrote it again. I'm going to tell you it's 2 twice. Okay, thanks. But you don't have to. All right, you could just tell me once. Mr. Roy and I will get the picture after one time. All right, so domain and range. All right, so this one kind of a combination of what you did in the last section. Graph it, and then identify domain and range. Did anybody feel like they really need to graph this, since we just did it? Right. I think what we'll do is let's just do this part. Identify the domain and range. Okay, that's the new part. All right, let's start with domain. Okay, what's my domain here? Oh, Kevin, can you give me one value in the domain?
Why?
Yeah. 3. All right, so we got that one. What else? Michaela? -1. All right. What else? How about, yeah, Victor? 4. All right. Sabrina, what else we got? -2. And one more. What's my last one? Kevin? 1. Okay, that's the domain. Okay, it's that set of numbers. The reason I wrote it in numerical order is it just makes it easier for me when I'm looking at it if it's in numerical order. Okay? If you don't do that, it's not wrong. But if you do that, I'll be very happy with you. And I'll smile when I grade your test. All right? So if you can put it in numerical order, that is nice. All right? And range. Hey, Ariana, can you give me a value in the range here that would... All right, 0. Yep, that's 0. Good. Caitlin, what else? 0, we got 2. Yep. What else, Ryan?
1.
Yeah, we got 1. So we got 0, 2, 1, and we got 2 more. Chloe?
It's another one. Good. Not sure.
Not sure. Michaela, can you help her out? Yeah, just those second numbers, -1, -2. Okay, again, I didn't write them in the order you guys were saying them. I just put them in numerical order. Okay, any question on that? Identify domain and range. Does everybody feel okay with the graph part, even though we didn't do it? I feel like you could do that. That'll be on the test. Okay. All right, let's see. Why don't you guys try this one quick on your own? You don't have to graph it. It's actually what we just did in the last problem.
So it's on the top, on the back side of your sheet.
See if you can find domain, range, and put it in lowest to highest. Okay, put it lowest to highest. All right, anybody feel really confident with the domain? Justin?
Yeah, I got it.
What's the domain?
Should I say it all?
You want to do it all?
I have
Go
it.
for it.
-1, 0, 2, 3.
Perfect. -1, 0, 2, 3. Sometimes if I have a big list, I cross them off as I go, so I remember I did it. And did you also want to do the range too?
Yeah, I didn't have that done yet.
Yeah, have that. It's okay. You got the domain. Anyone
Yeah,
want?
I can do
You
it.
can do it. You can do it on the fly.
Wow.
-2, 0, 1, 6.
1 and 6. Yep. Perfect. That's it. That's all you got to do. Identify domain and range.
You know, you'll do that in the homework tonight too, and on the test on Thursday. Not bad, right?
Okay. Now, looking at the domain here, -1, 0, 2, 3. Looking at our original coordinates, did we have any repeats? Did the first number appear twice anywhere? It did, Corey? Which one appeared twice in the domain? All right, I see 0 here. Where else do you see 0 again in the domain? Oh, you're just kidding. You're just playing with me.
Thanks, Corey.
All right, so no four first coordinates were the same. Right? They were all unique. Okay, anybody know the name of that? When all the first coordinates are unique. You never have a repeat.
They're all different.
It might be a tough one. It's not really a good hint I can give you. Right, it's called a function. Okay, so a function is a relation, but it's a special relation where none of the x's repeat. Some of the y's might repeat. Okay, I think we had one earlier where it was like the ages of the people, and there was a repeat in the y's. That's fine. Okay, if the y's repeat, or the second coordinate, that's okay. But we don't want to have that first coordinate repeat. That's called a function. Anyone ever, now that I put that up, anybody heard of that before? Function? A few people? Yeah, it's a function.
So you guys have that on your sheet. You have the two lines, and then there's 2 bullets. So that first one you're going to fill in with function. And they do not repeat. That's a function. Only the first set of coordinates. Only the x or the domain. If they don't repeat, then you have a function.
Right, so this is where identifying the domain and range becomes important. So now you've got to look at the first coordinates, look at the domain, then say, do I have any repeats? If I don't, I'm good, I'm a function. If I have a repeat, not a function. Right? And again, you might see a y value repeat. Who cares about that? If a y value repeats, doesn't matter. All you're focusing on is the domain. Don't worry about the range. Okay, anybody need some more time to copy anything here? We're good?
So then, what do you guys think if it says on the next bullet there, it says when the first coordinates, the domain do repeat, then it's what? 3 words. Not a function. Right? So that second bullet on the back side, you're you're gonna write not a function. That's when the domain or the x repeats.
But do you want us to put this from these two pictures?
If you can, generally, yeah. I probably won't give you more than like 4 coordinates at a time. I mean, if you had like 50 of them, that'd be hard to do. But there's only 5 of them, so. All right, Sabrina, can you give me my domain?
One, do you want all of them?
Yeah. Can you start with the smallest one? I know it's a little hard, but
-2,
yep, it's got -2,
-1,
-1,
1, 2,
2, 3. Here's my domain. Did any of those numbers repeat? No. Do I even have to look at the y values if I'm asking the question, is this a function? No, y values don't even matter. They want me to look at the y values because they're asking me to do this. Find the range. That's the only reason I have to look at the y values. I can already answer this question. Is this a function?
No.
No, yes.
Yes.
Yes. None of the x values repeated. They were all unique. Okay, so I already know the answer to that question. It's a function. Now I got to answer the last part of what they wanted. What's the range? Okay, yeah, Kevin?
Range is -1, -3, 3, and 5.
All right, so yep, we got -3, and you said that one twice, right? So I'm not going to write it
Once,
twice?
but I said it once, but if there is a function.
Yeah, it's already a function, and we'll just write it once in our list. So -3, -1, 3, 5. Okay. Now, I had a value that just repeated in the range. I thought I couldnn't have repeats for it to be a function. Only has to be the first ones. Good. Yep. All you got to look at is a repeat in the first ones, not the second.
Range repeat.
Okay. Same type of question again, little shorter. Find the domain. Find the range. All right, Jalen, what's my domain here?
6,
All right.
4, and 4.
Yep. 6. Now, what did you say? You said something twice.
Oh, the 4.
Yeah, the 4 repeated. So what does that mean if the 4 repeats? It's not a function. I don't even need to look at the y values. I already know the answer. It's not a function. But they want me to identify the range, so I need to finish up. All right, Ariana, what are my values in the range?
1, 2, and 3.
1, 2, 3. Yep. Notice here you have less values in the domain than you do in the range. That's something that if you see that, like a red light right away is going off. All right? Almost think of these values like this. Every guy over here is going to be matched up with something over here. 4, okay, if we go and look at our list, got matched up with 2. 6 got matched up with 3. Well, look at what's happening here. 4 also gets matched up with 1. See how 4 got matched up with 2 different things? That's a problem. You can't have 4 going to 2 different things at the same time. We might talk more about these kind of diagrams later, but it's the same idea. Can't have 4 matched up with 1 and 2. No good. Okay, so not a function. Okay, same question. You don't have to tell me the domain and range. I just want to know, is this picture a function? Okay, so what might it be helpful to do first if you need to?
find order there.
Yeah, you could find the coordinates and see what happens. Let's start. You guys got this picture on your note sheet? You're good? All right, let's start with the one that's in quadrant 2 at the top. Callan, what's the coordinate of that one? Yep, -2, 3. Alex, what's the coordinate just below?
-2, 1.
-2, 1. What are we thinking already? Victor?
It's not,
Not a function, how come?
they're both a -2.
Yeah, we already have a repeat in the x's right there. -2, -2. I don't even need to do the others. I already got a repeat in the x's. What do you notice about these 2 points? And how they're lined up? And this is the key. If you can see this visually, you don't even need to find the coordinates. How are these 2 coordinates lined up? Caitlin?
They're both 2 to the left.
Yeah, they're both 2 to the left, so they're, what do we call that when they're
Parallel.
not parallel, but they're what? Yeah, they're vertical. Okay, we got two dots, and they're in a vertical line. Anytime they're in a vertical line, those numbers right there are going to repeat. Okay, so that gives you a way to tell without even finding the x's and y's if you have a picture. Okay. So really quick, if you use that same test here, are there any points that line up vertically? No. If they don't line up vertically, that means every point is going to have its own unique x. Right? So is this a function? Yes. What do you think is going to happen here? We have 2 points that lined up horizontally. That means something's going to repeat.
But it doesn't matter if it's not the first one, it's the y.
It's the y. Yeah, if you found these coordinates, this is left 4, down 1. This one is right 1, down 1. Notice the y values repeat because they line up horizontal. We don't care if they line up horizontal. That's fine. If they line up vertical, you don't have a function. Okay? And there's a name for that, which we might get into later on. Okay. Any questions on that? All right. So just a couple quick reminders. I think we already mentioned. Grades close Friday. Because of the half day, we'll do our test on Thursday. We're already halfway done the material for the week. And your homework tonight is a worksheet on 10.1 and 10.2.